We're moving on to lesson 10.2 today, and that is going to be on polygons and quadrilaterals. Our goal is going to be to classify polygons and quadrilaterals. You do not have to write the highlighted part. Let's start by writing down a definition for what a polygon is. Yes, I want you to write these definitions down. You're probably going to have to push pause because mine is already written. A polygon is a closed plane figure whose sides are segments that intersect only at their endpoints. Okay, I'm going to move on. If you're not done writing that, you're pushing pause. You're also going to need to know what a regular polygon is. A regular polygon is when all sides have the same length and all angles have the same measurement. Push pause and try that now. Let me show you what they're talking about. Let's write down some examples of polygons. A polygon is a closed plane figure where the lines whose sides are segments that intersect only at their endpoints. So a polygon can look like a triangle or a rectangle. That's also a quadrilateral because it has 4 sides. It could look like this. It could be a kite or a diamond. In order for something to be a polygon, it has to be closed, meaning there's no openings, whose sides are segments, whose sides are straight, that intersect only at their endpoints. So these are endpoints right here, and that's where the sides are intersecting. Let's find some regular polygons next. A regular polygon is when all sides have the same length and all angles have the same measurement. So a square is a regular polygon. I'm going to do my best to draw a pentagon. Pentagon has 5 sides. Or a stop sign is an octagon. An octagon has a regular octagon might look like this. Now they can be irregular, quadrilaterals, pentagons, or octagons. It's just that the angles and the sides have to be different. Here are some examples of shapes that are not polygons. So something that's not a polygon is something that's not closed. So like this right here is not a closed figure. Or segments that only intersect at their endpoints. This is not a polygon because these lines intersect here. This also says a closed plane figure whose sides are segments. The sides have to be straight, so a circle is not a polygon. Or here's another example. This is not a polygon because it has curved sides. We're going to continue on with 2 more definitions. You're going to need to know the difference between convex and concave polygons. Convex is when any 2 interior points can be connected with a segment that lies completely within a polygon. Push pause and write that down. An example would be something that looks like this. Let's say you have a rectangle. No matter where you draw 2 dots, and connect that with a line segment, the line will be completely within the polygon, no matter where you draw the 2 dots. So I'm going to give you another example. If I draw a dot here and a dot here, that line will be completely within the polygon. Concave is the opposite, when a segment joining any 2 interior points does not lie completely within a polygon. Push pause and write that down. So this is a polygon. It's not regular, but it is a polygon. If I draw a dot here and a dot here, and I go to put a line segment between them, do you see how that line segment goes on the outside of the polygon? That's concave. So the first thing they're going to have you do is to tell whether a figure is a polygon. If it is, you're going to say what kind it is and say if it's convex or concave. If it's not a polygon, you're going to explain why. This is exactly what it's going to look like on your assignment. So let's make sure we read the directions and answer all of the questions. So this first problem, tell whether the figure is a polygon. Does it have straight lines? Is it a closed figure? Is there any points that intersect, not at their endpoints? This has all the qualities of being a polygon. So I'd say yes, polygon. If it is a polygon, classify it. Classify it means what's the name of it? So let's count how many sides. This has 1, 2, 3, 4, 5, 6. A 6-sided polygon is called an hexagon. Now we should know what these polygon names are. If you don't, you can always Google 6-sided polygon and see what the name is. And tell whether it is convex or concave. Now, if I draw a line from here to here, I see that that segment's on the inside. But what if I draw a line from here to here? That segment goes on the outside. Because there is a chance of this segment going on the outside, this is concave. Let's move on to the second one. Tell whether the figure is a polygon. This is not a polygon. If not, explain why. No, because it has a curved, I wouldn't call that a segment, a curved line. Because it's curved. So if you see a shape that has a curve to it, it's automatically not a polygon. That's all I have to do for this problem. I'd like you to try this problem right here. You're following all the directions. Push pause and try that now. Okay, so yes, this is a polygon. Now I'm going to count the sides. 1, 2, 3, 4, 5, 6, 7. That's a heptagon. And then if there's any chance of me drawing a segment and that line goes on the outside, it's concave. All right, let's keep moving on. We were just working with polygons so far. Let's move on to specifically quadrilaterals. There are 5 different types of quadrilaterals, and we're going to make a chart with all 5 of them. Quadrilaterals can be split into 2 different categories. The first category is a trapezoid. A trapezoid is a quadrilateral. I'm just going to abbreviate because we're going to have a lot of writing here. A quadrilateral with exactly 1 pair of parallel sides. Okay, so trapezoid is a 4-sided figure. That's what a quadrilateral means, with 1 pair of parallel sides. So this is parallel to this. Now this is the symbol that indicates that these 2 lines are parallel. There's another type of trapezoid that might look like this, where this is parallel to this. I mentioned before we wrote down trapezoid that there are 2 different types of quadrilaterals. One type is a trapezoid, the other type is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Quadrilateral with both pairs of opposite sides parallel. So a parallelogram is where this side is parallel to this side, and this side is parallel to this side. Now notice how I notate that second set of parallel lines. It has 2 arrows on it. Okay, I mentioned before that there are 2 different types of quadrilaterals. There's a trapezoid with 1 set of parallel lines and a parallelogram with 2 sets of parallel sides. All of the problems, or all of the other types of quadrilaterals I'm about to put down here are types of parallelograms. So let's start with a rhombus. I'm indenting it a little bit so you know that a rhombus is a parallelogram. A rhombus is a parallelogram with 4 congruent sides. So it means that it's a 4-sided figure that has 2 sets of parallel lines that are congruent. So this side is parallel to this side is parallel to this side, but we also know that all 4 sides are congruent. We learned to show congruent, you use a straight line. Another type of parallelogram is a rectangle. So this is also a parallelogram. A rectangle is a parallelogram with 4 right angles. So this side is parallel to this side is parallel to this side, and then to show you have a right angle, you use these boxes. One more. Square. A square is also a parallelogram. Why? Because it has 2 sets of parallel sides with 4 right angles and 4 congruent sides. So a square looks like this. It's a parallelogram with 4 right angles and 4 congruent sides. So on your homework, they're going to give you a picture of a quadrilateral. You are going to identify it as one of these 5.